Hey everyone, it's Professor Lamb, and we're going to go over module 6, 7? I can't keep track anymore. Module 6. So there's 3 parts to this assignment, and I think I'm going to start towards the end, because we know we need to create a new sorting benchmarks class. And so what we have to do is create an integer array of at least 20 elements, and we need to create 4 identical versions of that array. So I'm just gonna do, let's see, I think I'm gonna grab the numbers from one of these test files. That's only 6. Okay, so it doesn't matter what numbers you pick as long as the int arrays are identical. You probably don't want to have duplicate numbers at all. Oh, I already did that one. Okay. Okay, I think that's 21. Let's use program to double check. Okay, we got a random int array of 21 items, and I actually want it to be exactly 20, so I'm going to take out 21 here. And as long as your array has 20 items, it doesn't matter what order or what numbers are in it. But we need to create 4 of these. And what we're gonna need to do eventually is keep track of number of swaps for each sorting algorithm. So for right now, I'll just do let's call it this will be the number of swaps for the bubble sort. And then we'll have selection sort, insertion sort, and lastly quick sort. And the last thing we need to do is print out a bunch of statements, like number swaps and bubble sort. Oops. So the only thing we'll have to do later is replace the 0 with some new method that we add to all the specific sort classes. Oh, no, that's the right one. Alright, so I'm going to save this and we'll come back to it. So let's jump into the object versions of insertion sort and quick sort. And what we can do is just copy this file. So I just did a Control-C. And we need to name it object insertion sort. Alright, so let's go into this new file. And everything here is okay, except we're going to have to change this to an object version of the algorithm. Right now it doesn't exist, so we'll create it. And we can copy the insertion sort algorithm from the int version. So I'm going to grab everything from here inside the class and copy it over to our object insertion sorter. Let's see if I can clean that up a bit. Okay, so I wasn't liking the format, so I right-clicked on the package, and under source there's a format option. So the only thing we need to do to change insertion sort for an object array is make the array of type comparable, like we saw in the other classes. And we're also going to need to make the reference to any element of type comparable. And then, since we're using objects, we can't use the greater than operator. We have to use a compare-to method instead, but it'll actually look pretty similar otherwise. Compare to, and compare to returns either -1, 0, or 1. And let's get rid of this first. If the value on the left is greater than the value on the right, that would be a 1. So let's try greater than 0 and see if that works. I'm going to go back to our test. Oh, right. So we actually want a string array rather than int. We want objects. No worries, we can grab that from bubble sort. So we'll grab this string array. And we have to change this to string and this to string. Let's see if that works now. Yep. All right. So we have the object version of insertion sort, and now we need to do an object version of quicksort too. So let me clear up some space. I'm going to close all of these. And we can keep most of this code. We'll just make a object quicksort test. Let me double check to make sure we did something right. Object. Yeah, that looks right. All right. So we have an int quicksorter. Let's grab this algorithm. I'm gonna copy everything. Yeah. Okay, so now let's go through the object version of quicksort, doing the same thing. This is going to have to be a comparable. Let's go ahead and do this quick fix solution. And we're going to have to update the swap method. This is going to have to be a comparable. Oh, no, sorry, that one is not going to be a comparable. Because that keeps track of the index point. So this needs to be a comparable. And let's see, less than. Let's change this to array scan less than pivot value. So I think it would be that. We'll give this a test here in a second. And lastly, this just needs to be comparable. So it looks like everything compiles correctly, at least. And we got that one right. Okay, so we've completed the object insertion sort and the object quick sort. And now the last part is implementing the code for sorting benchmarks. And we're actually using the int versions of the sorting algorithms, but you're free to do it with the object versions of the class if you'd prefer. Either way is fine. So what I think I'm going to do is refactor each method in the int version of the class so that it returns an int value. We'll have to do this 4 times, but it'll be easier than it seems. So let's see if we can just do this quick fix, change it to an int, so that now bubble sort returns an int. Let's add the return statement. And what are we going to return? Well, we're not going to return temp. We're going to have to return the number of swaps. But right now that variable doesn't exist. So let's make a static field. We can just set it to 0 at first. And anytime this swap happens, we're going to increment that static instance field. That's it for bubble sort. Let's do a similar thing for selection sort. And then, so here's the swap for selection sort. So let's put it here. Oops. There we go. Let's go to insertion sort. Oh, actually, we want to save all these changes and do the refactor. There we go. So it looks like the swap happens here. It also looks like it might happen here. Yeah. And last one. Oops. We have to do the same with quicksort. So quicksort's going to be a little more complicated since there's recursive methods, but let's see what we can come up with. We're probably actually just going to want to return this method. Let's make a static class first. You know, what's interesting is we might not actually have to do this. There might be another way we can do this. So let's create that static field again. So a static field stays the same anywhere in the class. So it doesn't really matter. We don't have to like pass it in and out of methods. We can just edit the static field directly in this method, which handles all the swaps for quicksort. So let's just add it here. much simpler. And then we don't have to try to refactor the recursive method with a new int return statement. All right, let's see how this worked. Beautiful.